Hey everybody, my name is Scott, and today we're going to solve the best time to buy and sell stock problem on LeetCode. We're going to solve this problem using dynamic programming. Let's go through the problem definition. We are given an array where the ith element is the price of a given stock on day I. If we're only permitted to complete at most one transaction, the transaction being we buy one and sell one share of the stock. So that's key for this problem. We're only doing one transaction. We get to buy at one point and then sell at one point. Design an algorithm to find the maximum profit. So here's an example for these are the prices of the stock at each day. 7, 1, 5, 3, 6, 4. The output's 5. And the reason is because the maximum difference here is 6 minus 1 is 5. See? So in this scenario, we buy when the stock is 1, and then we sell when the stock is 6, ending up with a profit of 5. It's not 7 minus 1 equals 6 because we're not buying when it's high and selling when it's low. So that's key. Like in this problem, 7, 6, 4, 3, 1, we output 0. Why do we have no profit in this case? Well, because it's a decreasing array, right? So regardless of whenever we were to buy, if we were to attempt to buy on any of these days, the stock will always be worth less in a future day. So there's no point in ever buying. We can't make any profit off this. Output 0. So we're going to use dynamic programming, and as in any dynamic programming problem, we need to come up with a recurrence that relates solutions to smaller problems, solutions to subproblems, to a general solution of the overall problem. And this one's interesting. It's fun to think about a little bit. So obviously we're developing a recurrence. Let's think recursively. Let's say that we can solve the problem. We have a solution. We know the answer for the max profit up through day I. How can we extend that solution to the solution for day I plus 1? Well, since we know the max profit up through day I, that's a pretty good start. The other thing that we need to keep track of is the minimum price the stock has reached in the previous days. Because if we know the minimum stock price of the days up through I plus 1, then we know that the max profit we can earn on day I plus 1 will be the price at day I plus 1 minus the minimum previous price we've seen. So we compute that, and then all we have to do is determine, well, is that value, that profit, greater than the profit that we calculate, that we know from day I, the max profit from day I? If it is, then our new max profit is that value, the price on day I plus 1, minus the minimum previous price the stock has been in the days leading up to that. If it's not greater than the max profit from day I, then we just keep our max profit at the profit of day I. So that's the recurrence. Let's implement it. Now, with any dynamic programming problem, we can use tabulation or memoization. Memoization being we solve the problem in a top-down fashion recursively. Tabulation, we build the solution in a bottom-up fashion. In problems like these, where we're remembering information about previous days, trying to keep track of previous data, I like using tabulation a lot. And just makes the logic a little easier when it comes to extending the problem. So we're going to use tabulation. First thing we're going to do, we're going to make sure that the prices array is not empty. Make sure they can't catch us with that edge case. If it is, we just return 0. Nothing special there, just making sure that we don't get caught by that edge case. So when we're tabulizing, we're going to keep this data, which will remember our previous answers. So again, all that is the integer array dp is keeping track of the previous answers. So dp of I is equal to the max profit up through day I, from day 0 through day I. And like we said, we need to keep track of the minimum previous price, because that's what we're going to use to calculate the current profit we can gain. And we're going to initialize that to prices of 0. Prices of 0 will kind of be our starting point, because we can't gain any profit on the first day. We're buying and selling on different days in this scenario. So we're just going to initialize these things at the first day. We're going to say our max profit is 0. And we're going to initialize our dynamic programming array of 0 to be 0 as well. So remember, this dynamic programming array represents the max profit we can earn at a certain index. So the max profit we can earn at day 0, the first day, is 0, because we can't buy and sell on the same day. So now we just have to loop through the array, starting at 1. And update our values accordingly. Now remember, we came up with that recurrence, and here we're going to implement the recurrence. So dp of I, which is, remember, the maximum profit on day I that we can earn, is equal to, well, if prices of I, the price of the stock at day I, minus the minimum previous price we've seen, is greater than the dynamic programming solution at I minus 1. Now remember what this is saying. This is saying the price at the current day minus the minimum previous price we've seen up through this day is greater than the max profit of the previous day. If that's the case, then our new value will be prices of I minus the min previous price, because that's basically our new maximum value that we can earn, our max profit. If it's not, then it just becomes the maximum profit from the previous day. So again, this is just the recurrence relation we came up with. The max profit at day I is equal to, and this is a ternary statement. If you don't know much about ternaries, just go give them a quick read. They're not terribly confusing. If the price at day I minus the minimum previous stock price that we've seen through this day is greater than the max profit of the previous day, then the max profit at day I will be the price at day I minus the minimum previous price through day I. If it's not, then the max profit that we can earn is just the max profit from the previous day, dpi minus 1. And then we just have to update our values. The minimum previous price is equal to, well, if prices of I is less than the minimum previous price, then it'll be prices of I. If it's not, it just remains the minimum previous price. And we also need to update our max profit, because that's what we're going to return. So if the profit that we earned on day I, dp of I, the max profit at day I, is greater than the max profit we have so far, then it's going to be dp of I, which again is the max profit at day I. If it's not, it's just going to remain max profit. And finally, we will return max profit, max profit. Alright, let's see how that came out. Alright, let's submit the solution, see what happens. Alright, accepted solution, cool. So, pretty straightforward dynamic programming problem, kind of a cool problem. Again, what we did was We developed a recurrence which solved the larger problem in terms of solutions to the smaller problems. And once we do that, the gig is up. It's pretty much game over from that point. All we got to do is implement it. So again, when you're faced with a dynamic programming problem, be sure to get that recurrence right. That's the big step. Once you have your recurrence right, it's just a matter of, am I going to tabulize the solution or am I going to memorize the solution? In this case, we tabulized it by using this DP array, and we built the solution from the bottom up. So that's all for this video. Hopefully it was helpful to someone out there, and we'll see you next time.